welcome to this webinar. It is part of our, let's say, journey of upskilling and reskilling of various, in this case, the education sector. I'm the Chief Administrator of eSkills Malta Foundation. Since we introduce quickly ourselves, basically I've been, well, I'm an old man. I call myself an old man. But anyhow, I've been in the IT industry for over 40 years, probably between 40 and 45. Obviously, my thought, obviously, I started from coding as many others, but then I went up to C-level, managing companies, and eventually in the last, I think 8 years, I took over at eSkills. Our objectives are very clear. However, we've got a wide, let's say, contribution to education, to SMEs, to society, and also to the ICT community. So we try to let's say, although we do everything, but we focus on things that are of goals that are required basically by the country. So this webinar is about robotics in education. As a brief agenda, we'll have a panel discussion about the subject with the panel members of Robert and James. Then we have Savio College giving us their experience, especially in the Rome Cup, and St. Benedict's School Secondary on their experience and how they're doing robotics in the classroom. And then eventually there is Nathaniel who will talk about the robotic classes and also his involvement in Schola Side. As you know, robotics plays a pivotal role in education. We have been obviously preaching this for a long time. Let's say both James probably and Roberta, they had to challenges and to convincing people about this topic, and we also had our challenges as well in explaining to basically not just to the administrators of school, but also to the schools and headmasters and leaders themselves. Obviously, they have some autonomy, although they put the policy of their ministry or in the case of the church. However, they put autonomy in schools as well. We think it's important and crucial because it fosters creativity, problem solving, and it integrates with the curriculum. It also brings, let's say, the subject of STEM, let's say STEM and not, computer science only, in a fun way to understand the concept and the subject. As you know, the concentration of both of youth and adults is limited, and the more interesting we do it, the better. So let's jump into the panel discussion. And basically, the panel discussion will be on the same subject. And just as an introduction, although we're obviously now we're recording, I'm going to say a quick introduction for James, who is the head of the Department of digital literacy within the Directorate of the Digital Literacy and Transversal Skills. He's also the EU Code Week Edu Coordinator, and he represents the Ministry of Education. I'm saying it in short because there's sport with youth and research and innovation. We have been working with James for quite some time. I think we exchanged good ideas. We were both open, and you know, probably sometimes he sees a couple of horns coming out of my head because I tend to, let's say, change things to make things maybe more expand things. Roberta Tapanemaggini is the same in the chair schools, head of the Department of Digital Literacy and Transversal Skills. However, Roberta is an engineer and a STEM educator. And she holds degrees in electrical engineering, proset, Roberta ma kontx naf, u science education and digital education. Jina sejħilhom daw pilastri. Hawnhekk irrid ukoll nakknowledġja lill-Angela li ma semmejtix qabel. Angela is administrator in the chair schools. She helps a lot. She helps me personally and the foundation a lot because we send a lot of information to disseminate to the schools, etc. And I know that these days it's a very busy world in our sector, especially. So we're always coming with opportunities to learn for teachers. I have to say that there is a challenge, let's not call it a problem, with all the world, Europe and Malta as well, in the participation of let's say, teachers in these things, because obviously they are busy with their lessons, you know, so there are reasons for this. So we try, but we never stop because we're partners of many other international organizations, and they come up with these days ready-made courses. So I want to address James to start with. In the modern education, James, how would you define a robot? What is a robot? If somebody asks you, okay, listen, robot, because obviously different people think different things.
So let's start first of all, as we all know, and its effect nowadays, robots are widely used in society and in all industries. So that brings us to a very important point to familiarize students with the robotics from an early age. And in fact, in schools, we focus on educational robotics, which might differ from the notion of robotics that it is used in other sectors. And you've touched a very important point. In one of my early lessons with students, I posed the same questions to students themselves. What do you think a robot does? And obviously, they have perceptions from what they see on television or on any other media they are familiar with, and they tell you a lot of things about what robots do. And from that notion, then we will focus on the basics or on the primarily use of robots in education, where we focus on nurturing both coding and computational thinking skills.
So you saw an impact in robotics in the STEM subject, because obviously yes, this is always a question by parents, by everybody, obviously, by the peers. These robotics, are they toys, you know? So, but you've seen an impact. Have you seen an impact on the STEM subjects?
Yes, definitely. In fact, I was going to say that education is not an exception here, because robots or educational robotics are very important, and we have seen throughout the years through the application of STEM subjects, we have seen that students are becoming more oriented towards STEM, even STEM careers later on. When they finish formal schooling, they are more oriented towards that area. And we must also add that nowadays, students, it's very, very important, and this is backed by literature, to give them all the opportunities to work with robots or educational robotics to nurture first coding and, most importantly, computational thinking skills. And we have invested a lot in our schools, both through resources and programs.
I will ask you that question later, in fact, so post it for now.
Okay.
Or else later on you will have to think of it again. Roberta, what have you observed as benefits of integrating robotics in the students' curriculums?
I think one of the strongest things that I have also seen is the strong impact on skills, on the students' soft skills, such as thinking critically, where they evaluate the problem, and that it goes with it are the problem-solving skills, which James also mentioned, integrates so smoothly with computational thinking, where they break down the problem. You see them also discussing, so you get that, and building on each other's ideas. You get also the collaboration aspect of it. They identify common patterns to make it smoother and more. I think computational thinking also adds to problem-solving skills because it helps them. It enhances their efficiency and their effectiveness of problem-solving, and it is something that they can adapt to everyday life. So problem solving, we all encounter problems and constant challenges. But another aspect that I really believe strongly about and have observed is that the students, through robotics, so it's fun, it's playful, and it is a safe learning environment. And given the type of debugging that goes the process through it, where you create a problem, the program, the algorithm, you test it, you refine, then and if it fails, it's okay to fail. I mean, it's usually we see failure as negative. Now, I think something that I have observed that through robotics, what it gives the students is a safe space to try again, leading to other skills such as resilience, grit, persistence. So I think robotics really, I have observed it even with students who have learning difficulties. It gives them the
a quick question. Sorry, I'm interrupted because I'm sure that Marisa is keeping the time, so she'll soon start telling me, "Hey, calm." However, do you see a change in styles as well with robotics on how to teach?
Styles, you mean with educators?
Yes. So do you see, when you're teaching computer science or subjects, and let's put it this way, it's basically engagement is not always there because obviously it's a teacher, the engagement of students with teachers. So parallel learning styles.
I think it addresses, yes, it helps, because we have students who in the traditionally using the book and it allows, it has a variety. So it provides various ways how the students can integrate to their own learning style at their own pace and level. I think robotics offers, we have the different robots we can have robots that are simple and easy to use for certain types of students and their style, but it offers the tangible aspect also, that you can build your own robot. So we have those that are more kind of, like enjoy using their hands and manipulating objects. And then we have others who prefer text-based, like going into detail. So I think it offers a variety and it can reach students' different abilities, interests, and they can learn personalization of learning. I think it allows for that, even with assistive technologies and that can be integrated in certain robots. So yes, I believe that robotics offers this variety to all levels of students.
I want to ask this question to both of you actually, because obviously we won't be able to address all the questions that I have in mind. The challenges for schools, what challenges do you find for schools in integrating robotics into their curriculum? What challenges, let's call them problems as well? And attached to this, obviously, how can they be made more accessible and affordable for schools with the limited resources there? So to start with you, James, what do you think? What are the challenges and how can robotics be made more accessible? I think at this point, James, because there is a specific question on this, but we might put it here as well. You can also mention maybe some initiatives, within the ministry which you're doing that addresses these things,
First of all, Carm, to answer this question, top in the list, we always find budget. Schools do not have ample budget to invest in robotic kits because, as we all know, they do not come cheap. So that is the first issue, and maybe a solution to that could be is to find partners outside the school community who might be ready to help in this regard. So that is the first issue of all. Although in the past years, the Ministry for Education have heavily invested in this area, continuously invested in this area. Second, I think teacher training, because we might find teachers who, apart from not being aware of the benefits of education robotics in the education, they might lack training. So that is also an issue. Curriculum integration as well. We're talking about STEM subject here, but you need a framework with specific learning outcomes addressing these STEM approaches to further highlight the importance of education robotics in education. There are a lot of issues here. There are also technical issues. You need a person within the school community who maybe has more expertise than his colleagues, is the go-to person, so as to define this role where teachers can refer to if they encounter teething problems while implementing educational robotics. And most importantly, assessment methods. We cannot sort of assess projects, STEM projects, with the traditional approach. We have to cater for example, the creativity, the amount of collaboration and communication taking place during STEM projects. And most importantly, it's Roberta has mentioned this as well, is the important, you have to acknowledge the whole process, let's call it it is called the engineering process that students go through to reach to the final solution. So yes, those are the problems. Some solutions could be, for example, and we are already using this approach with other resources. Maybe a pool of education robotics could be forwarded to the head of college network, and these can be shared among the different schools within that college. That is a formula we are using with other resources, and it's coming to fruition. That's for sure. Most importantly, also, but this we have to be very cautious here. We have to find the right momentum, where and when, if this approach is implemented, when and where the resources are used, matching the curricular aspects that teachers will go through during specific timeframes. So yes, there are difficulties, but there are solutions as well.
Okay, Roberta, obviously, since you both you have the same roles as James, I think you're gonna repeat, but maybe you can additionally also mention some things which in your view, the way I conduct things like this. There is the official aspect, which means obviously what the church or ministry dictates. And obviously, however, sometimes the personal view also helps without being controversial, I would say, So please feel free to expand on that.
As I think, I will just, as James said, I think he has targeted a lot of the issues. So again, the access to resources, but I would not like to, I mean, we're also trying to invest in resources and also to support schools. But from our end, we also try to support teachers. I think cross-curricular integration is one of the greatest challenges we have. Both in primary, but also even more in secondary, sort of to take a STEM approach, especially for maybe in the secondary, it is more, the subjects are more separated, so we have scheduled times. Another issue is that we are trying to deal with is, rather than just giving a professional development to teachers, we try to also accompany them, like we take a process, like we accompany them during sessions, like with co-teaching, but then also being there to mentor them and provide guidance when they reach out according to their needs. And that is also a time-consuming process.
Let me ask you a specific question, which obviously I'm going to ask you only at this point. You mentioned, or James mentioned, which you probably agree is about accessibility and about budgets. Obviously, that you have partners helping you. So, for instance, tech partners. Well, however, how do you deal with the aspect of equilibrium? Unfortunately, in Malta, we're very sensitive. So if you do something with Microsoft, somebody else might come on now and say, well, hey, we can do things like Microsoft, how do you deal with that? Is it something that you find difficulty in, because there are lots of companies these days, that can.
I believe we try to work with everyone. I mean, we are open to working with everyone. With all suppliers who are ready to give us a helping hand. I mean, the importance at the end of the day is collaboration and networking. We try our very best to work with all areas as much as possible, because we believe in working together for the benefits of our students. I really do believe that's the way we try to work.
Marisa, can fadalli, please?
We have exceeded with 4 minutes, but if there's another question which you would like, then we can proceed after. But ideally, we keep it short.
Maybe it's good to before maybe I ask a quick question and answer, but how can I say? We engage a lot with this thing of robotics and all that. However, I always preach to, as much as possible, you connect the robotic aspect with the subject, with computer science, because even in exhibitions you see kids playing, and it gives you the impression that they actually treat robots like games or tools, or you know, so maybe the aspect sometimes is forgotten, that when you're dealing with this robotics aspect, it's very important to connect to the subject. And I think that is key because, you know, youth and kids, you know, they grow up, and if that connection is lost, then obviously, okay, James and Roberta, some quick, let's say, successful
Maybe we keep it 2 minutes if
projects
we can. Yes.
in a minute each. Some projects which were successful in your sphere.
One of the projects that we are currently implementing, Karma, in fact, it was sponsored by eSkills Malta Foundation, is the computational thinking program, where we have a school in each college, which was forwarded a number of resources targeting all the years of primary education. And we are currently implementing the project by going through a curriculum mapping exercise. And as Roberta mentioned as well, we then move to co-teaching sessions until teachers are then familiar enough with the resource to use it to use them in other curricular areas. I kept it very brief.
Okay,
you.
yes.
I will just give a way that we went about with a robotics across the curriculum with a school where we worked with, first we had a professional development on computational thinking and robotics. Then we went on to helping educators during curriculum time. We worked with them where they where we prepared the lessons together, tweaked across the curriculum, you know, like the learning outcomes, and we saw how we can best adapt the lesson. We did co-teaching with them. This was during the first year. Then at the end, we had evaluation. The second time round, then the evaluation with the SLT and everyone, learning support educators, they were all on board. In the second time round, then it was the educators who took on the role of ownership of preparing, and it was a very successful implementation of robotics in that school. So they took it on, and they invested in resources, in robotics. They saw the importance of it, even with the parents getting them on board. So, and we are there now helping when requested, like for mentoring with difficulties. So yes, it was a very successful implementation.
Thank you. Thank you, James and Roberta, for your answers and interesting, let's say, methods that you use in highlighting them. And now I'd like to a quick introduction to Charles Axisa. Charles Axisa has been teaching in computing at various levels for the last 30 years, and robotics for over 15 years. Probably that's the time when robotics started as well, getting into the mainstream. He's passionate in programming. He specializes in Java, C++, and Python. Very interesting, as well as robotics. Obviously, robotics these days, you can program them, especially those advanced ones. Throughout his career, Charles has had the opportunity to guide students in numerous competitions, both locally and internationally, in fact. Although teaching presents a number of challenges, Charles finds himself enjoying and fulfillment in his profession. So now, Charles, obviously, Marisa, now it's Charles is no Fidel Charles Mohra.
Okay. So, first of all, I'm going to talk about the way we conduct robotics at Savio College. In Savio College, robotics is a subject. It's a subject option. So we have 3 years devoted to robotics. Just like they choose, I don't know, computing, just like they choose chemistry, biology, okay? Students can choose robotics. The subject is called robotics and single board computers. We have a 3-year course. In the first year, the students are exposed to basic electronics, okay, like voltages, amps, and all the stuff. Okay, the use of the breadboard, use of Arduino, the use of the C language to program, okay, and use of PWM and other signals, okay. And they also do projects like, for example, designing the board, the connection board for a washing machine, or for a I don't know, for a microwave oven, for example. Okay, so they have a whole spectrum, or a simulation of a car park. They have to build a car park and make it work. So they have a full spectrum of projects during the first year. In the second year, they learn how to solder wires, how to solder pins. Okay, they learn CAD, because they have to design their own parts. The focus in the second year, between year 10, is that they have to build their own autonomous robot. And that is where we take part in RoamCup, which I will speak about later on. The final year, third year, which is year 11, we focus on single board computers and computer vision. So the students have libraries like OpenCV, and they learn very basic stuff about image segmentation, for example, blob recognition, or recognizing everything in coding. Okay, throughout the 3 years, the students learn both Python and C, because the first 2 years they program in C, and the last year they program in Python. Now, as regards to challenges that we find in this program, first of all, it's something that you already mentioned, Carl. Sometimes, I don't know, it's the general concept here in Malta that robots are a game. They are some sort of a toy, you know, that you give the students to shut up sometimes. So it's not actually that. That's, I think, the first problem that I clear up with my students. Okay, this is not a game. We're not playing here, of course, but they in the it's not a game. Okay, so that is the first thing. Other things is that this blessed subject is not just one subject. It's a mixture of subjects. You have engineering, you have design, you have many aspects, maths, physics. You have many things. So even a subject like computer, for example, or English, there is one subject that you have to be worried about. In robotics, there are many subjects to be worried about. So what I am saying is, for example, a student writes code. He's convinced that the code is okay. Okay, okay, then tomorrow, the day after, doesn't work. So what's wrong? Is it the code? No. Is it the sensors? No. It was the wire. The wire got loose or something. So there are a lot of challenges in teaching robotics. I teach computing as well. And believe me, teaching robotics is tougher than teaching computing. You have to be well prepared. Even you're working, sensors get burned, all right, hara sensor, hara LED, all this stuff, hara microcontroller, right? These are things that happen. Plus that one has to add also the manual aspect of it. Okay, in year 10, I have students drilling, I have students soldering, so I have to be careful going around and see. You have to pay attention if someone gets hurt and all the stuff. Okay, to keep with time. As regards the RoamCup experience, first of all, RoamCup is an event, it's a robotics event, a big robotic event that happens in Rome, that's organized in Rome, and it's not just competitions. You have talks going on, exposure areas, demonstration areas. Okay? It is usually targeted from 16 plus, so our students are the younger ones. Okay, but it's a very interesting event. And of course, there are the areas of competitions, and we take part in one competition which is called Rescue Line. It's basically a competition where the robot has to follow a line, and not a very simple line. It has to detect green patches on it. It has to overcome uphills and downhills, seesaws, speed bumps, and then it has to go in an area. There are victims waiting, has to save the victims, put them aside, put them in a box, sort them by whether they are alive or dead, because the robot has to distinguish between victims that are alive and victims that are dead, and has to then go out and carry on with the line following. It's quite a tough challenge. I chose that challenge because it fits nicely in our second year program. All right, it's second year in year 10. So even if we don't go to Rome Cup, if we don't experience Rome Cup, okay, we still go with that competition. We organize it at school. So, but since 2018, we have participated and got good results in the competition. Of course, with a competition like that, there are a number, again, of difficulties. First of all, in my experience, the biggest challenge is time. You have to manage time. So that is why we spend a lot of time after school hours. Okay, so usually I calculate normally that we spend around 150 hours after school. Okay, some people told me, why do you spend all that time? Because they have to do everything on their own. I assist them, I help them, but they have to build the robot. They design the robot. We designed it using CAD. We print it here with our printers. We don't use standard or commercial packages. We have everything here. We do our things here, okay? Even anything. We just buy sensors and we just buy the hardware without doing any efforts, all right, or whatever. In either case, they have to do their own work, and it's pretty tough. It's pretty tough. And also, your role as a teacher is not just a teacher. Sometimes you end up being a psychologist or whatever, because you have to make them, students by default, they are not that mature. So you have to make them believe in themselves. You have to make them, listen, we're going to make it. We're going to make it. It's not easy, but we're going to make it. You have to convince them. Sometimes you have to convince them to work, because sometimes they don't really understand the level of the competition. And also, since it's a lot of time, 6 months of preparation, okay, sometimes students, they just lose it, okay, and you have to put them back in track. But besides that, it's a very nice experience. I enjoy it every year. Nispiċċa bla saħħa, right? I'm getting old and it's getting tougher, but it's really a very nice experience. It's not easy. It's not easy because guiding a number of teams, this year I had 4 teams, okay? Guiding 4 teams with all their problems, different hardware, because the robots are different. 4 different robots, they act differently. Okay, they are performing the same task, but they act differently. And you have somehow to deal with all the 4 of them. Sissa wasalt, right? I don't know what's going to happen in the future.
No, okay. Obviously, a quick question, because it's called the Rome Cup. So it is held in Rome? Is it held in Rome?
Yes, it is. It's held in Rome.
Okay.
Now we have the video, which eSkills Malta Foundation came to our school and filmed our students. I don't know if I can comment while the video is on. Can I? Or there are the kids talking,
yes,
right?
they will be talking, yes.
Okay.
Maybe you would like to comment before or after?
A little bit afterwards, if
Okay.
you don't mind. Thank you.
Yes, you're welcome.
Thank you, Chas.
Hawnhekk qegħdin Savio College, reċentement ħadna sem f'kompetizzjoni Ruma. Fija tħallna f'żewġ kompetizzjonijiet differenti. Tħallna fl-Explorer u tħallna fil-Rescue Line. Hawnhekk miegħi għandi t-tim illi ħasem fl-Explorer. Għandi l-Nicholas Bird, l-Raffael u l-Liam Gafa. Fil-kompetizzjoni ta' Rescue Line tħallna b'4 timijiet. Hawnhekk għandna lil-tim Dave, li huwa magħmul minn Jaden, Bradley, u Matthew, għandna tim Luca li huwa magħmul minn Isaac u minn Andrea, għandna tim Philip li huwa magħmul minn Benjamin, minn Jaden u minn Liam. U finalment għandna lil tim Domenico li huwa magħmul minn Gabriel, Luigi u Cayman.
For this competition, we started with the base, then all the coding, building, and the design were made by us.
The designs were made using a CAD program called FreeCAD. With FreeCAD, we designed bumpers and brackets, and also we designed the base for the robot.
So for my team, I was the main coder, and from my experience, I can say that we did face a few challenges. Some in the line following the first part and some in the rescue area, the second part. But we managed to overcome them with a lot of testing.
In my team, I took care of the hardware, wiring, and designing of the parts. The wiring was a bit of a problem because it was loose and sometimes the sensor would not work and there was no reason why. And we printed quite a few brackets because the measurements were wrong or we needed a different part for that piece.
Well, for this competition, we used Arduino IDE and the language was C. We've been using this for the past 5 months as we were working on the competition, and it's a pretty basic language, but it takes some sense to code and stuff.
And we split the code into header files, but with the header files, we split them into voids, methods, so we could make the code simpler. For example, if we have 5 lines of code, we can make them into 1.
Not only for the exit but the entire rescue area, we used these sensors called the ultrasonic sensors, which can detect how much distance there is between the robot and the wall. And this way we could kind of make laps around the area trying to find the balls, and it could also detect when there was a hole in the wall, which was the exit.
To follow the line, we use the PID algorithm. This is used for the robot to keep in the middle of the line and to turn accordingly while adjusting the speed of the motors. The PID algorithm is not only used in line following, but it is used in CPU cooling systems to keep in autopilot to keep the aeroplane's altitude at constant, and in 3D printers to make sure the temperature is kept at constant.
The highlights of the competition were mostly 4 of the 5 teams qualifying, and our team getting first place, another team getting second, and another team getting third place.
Other notable experiences we had in the competition, outside of the competition, was when we went out every night eating together as a team and as a whole squad, including the teachers that were with us. And also we went shopping in the Termini train station, and we also went out to popular sites in Rome like the Vatican City and the Colosseum.
Obviously, there were a lot of skills that we used and learned throughout the competition, both academic and moral. On the academic side, we learned how to 3D model, how to use different sensors, soldering, also coding algorithms and using the PID algorithm.
On the social side of things, we learned to work as a team, as teamwork was a good base for everything, as although we were in separate teams, certain circumstances, for example, if a sensor stops working and we're in a rush, especially in Rome, we had to help each other because at the end we're all one team.
So our team was divided into 2 main tasks, which are the programming and the engineering.
At the start, everyone did a bit of everything, but once we got into more detail and the competition got harder and everything was getting more complicated, we split into 2, which were the engineering and the programming.
So the engineering side, there was the 3D modeling, the wiring, and the soldering.
In programming, there were 2 main parts, which was the code of the actual robot and the code of testing, which we used to test all sensors to make sure that they work.
For future participants, the advice I would give you for this great experience is that you have to always be committed, and the tasks you have, you must finish them. Even if you fail sometimes, you always have to try and try again, and you have to be prepared to make some sacrifices along the way.
Although we face many difficulties during this competition, you need to keep an open mind and always beat them.
Process, just really impressive, and you could see the why robotics is so important, because you know they are so outgoing, helping each other.
Yes.
Which eventually that's what work is. Even if you work in the ICT, you're gonna face the same problems, maybe at a different level, but it's the same problem. You wanted to say something, Charles, I believe.
Yes, just a small part. It was, as I told you already, it was really a nice experience. Every year, it's a nice experience. Whether we win or not, it's irrespective whether we win or not. It's not important. It's not that important. The most important thing is that they learned a lot of things, some of which are not examinable. So they are just skills. So, but they are useful for their lives. That's all I can say. Thank you.
Cross it, keep it up. So now we come to St. Benedict's College. Well, I'd like to introduce Mohammed Ben Hadi Salem. I hope I did it right. Okay. Who is basically a dedicated computing teacher with over 17 years of experience in Tunisia and now teaching in Malta. He had the privilege of shaping young minds in computer science, which is a nice thing to do, obviously. Since moving to Malta in 2022, he continued to inspire and educate secondary school students. He founded a robotics club, which is great because extracurricular activities are as important as actually curricular activities, because they have a different objective as well. Actively engaging students in competitions such as Code Sprints, which the foundation has been sponsoring this event every year because we really believe in it. And the EU Code Week. Moreover, he's committed to inclusion, which is very important, and to ensure students with disabilities to have an opportunity to excel in coding and robotics. So, Mohammed, I think it's your floor now.
Okay. Can I share my presentation, my PowerPoint?
Yes, a moment. Yes, feel free.
Good morning, everyone. First, I would like to express my sincere gratitude to eSkills Malta Foundation team for their support and for providing us with this wonderful opportunity to share our work. A special thank you to Chief Administrator, Mr. Carmel Kakia, for introducing me today, and to Ms. Marisa Abella, the project manager, for her encouragement. Before I begin, I would like to quickly outline today's agenda. So I will start by an introduction to basic robotic kits and educational tools. Next, I will discuss the benefits and examples of robotics in inclusive education. And lastly, I will introduce a student project where an automatic barrier gate was built using Arduino during the visit of the eSkills Malta Foundation team to my classroom. So let's start by an introduction to a simple robotics kits and tools. I will start by this question. What is a robot? So a robot is a goal-oriented machine that generally can sense, plan, and act autonomously. So what do each of these means? So sense, it means that the robot is able to sense the environment and knows what is going on around, such as there being a wall, for example, 4 centimeters away from it. A plan, it means that this robot can make decisions based on the environment, such as the robot should move away from the wall, and act means carry out this decision. So if we want to explore this in more details, consider the robot car on the right. How does this car know if it will run into a wall? So the robot has to sense its environment. So the car, you can see here, has eyes. So these eyes are in the form of an ultrasonic sensor, which let it see what is in front of it by sending sound waves out and measuring how long it takes for the sound wave to return. Here the subjects, they overlap. Here we are going to use some formula in physics also to calculate the distance and the speed of the sound wave. That's very important. What does it mean to plan? So this robot car have a goal to drive around without hitting a wall. It could then plan only to drive forward if there is no wall in front of it. So the program running on board, so which is the microcontroller, is a small computer. So this small computer will execute the instructions to process this instruction to give control to our robot. So the car drives based on what it senses. So the plan, turn when you see a wall, helps achieve the goal. Don't drive into a wall. What does it mean to act? So the action a robot takes in the real world is done in the act step. Consider the car again on the right. How would it act to change direction if it was driving into a wall? So the car would act by steering away, turning its wheels in a different direction. If there was no wall, it could steer straight away. Then we can see the 3 steps: sense, plan, and act. So putting these 3 steps together, we can see how this robot can achieve a goal of driving on its own and avoiding walls by following the 3 steps, which are sense if there is a wall using the ultrasonic sensor, plan to change direction or continue based on whether or not there is a wall in front of it, and act by moving the wheels, what we called also the actuator. Let me move to the essential tools and equipment to do this simple project. For this project, we need to use a microcontroller. So what is a microcontroller? It's a brain, it's a small computer, serves as the brain of the robot. There are popular choices, including Arduino, Raspberry Pi, Microbit. So these small computers are user-friendly and come with a vast online community offering support and project ideas. Sensors also we can see that are the eyes and ears of the robot. So depending on our project, we need various types of sensor. For example, if we want to measure the distance, we use ultrasonic sensor. If we want to measure the temperature, we are using temperature sensor. If we want to respond to physical contact, we use touch sensors. And another devices are very important. We use in class to create robotics projects are actuators. So actuators are responsible for moving and controlling various parts of the robot. For example, we can use servo motors to control robot lamps, DC motors for wheels and other continuous rotation tasks, and the most important tool also is to use what we called an integrated development environment, because this digital system or this robot without a software will not work. So we have to program the robot. So to program the robot, we need to write the source code. We compile it, we test it, and then we upload it to the microcontroller to this robot to be functional. I will move on to the second part of my presentation, the robotics in inclusive learning. So inclusion in the classroom means that all children, no matter their racial, religious, or ethnic background, gender, learning, style, or ability, have equal access to educational opportunity in a learning environment where all students are equal, safe, valued, and respected. Every child has the right to quality education and learning. By experience, teaching robotics has shown that children with special needs, especially autism, who interact with their robotics projects improve their social interactions and communication skills. How robotics empower and foster inclusion education? Let's ask these questions. Robotics kits, and I am teaching robotics because it's a part of our syllabus in computing secondary schools year 9. These kits, like Arduino, for example, kits, they are learning mediators. They combine the reconstruction of the knowledge key obtained during school activities and foster students' social emotional learning competency while equipping them with essential 21st century skills. So educator, his role, not only to transmit the knowledge to the students, but will play the role of facilitator, guiding them. So we are encouraging students to be involved in these projects. So these skills, I can mention self-awareness. So robotics encourage students to reflect on their own strengths, weakness, and emotions as they work through challenges and interact with their creations. So when students encounter errors or bugs in their code, guide them through a structured process of identifying the problem, understanding why it occurred, and reflecting on how they can avoid issues in the future. The students here they have a safe learning space, so they can fail. So no problem, they can repeat again, they can correct their code. We find it as a teacher a very important, let's say, this self-awareness. It's very important for the students, even for his future. So we focus on these life skills. Self-management. So engaging robotics requires students to manage their time effectively, set goals, and learn to regulate their emotion, and stay focused on task, developing crucial self-management skills. Another important skill that working collaboratively on robotics foster social awareness. So robotics projects exposes students to diverse perspectives and teach them to empathize with others. So they learn to communicate and cooperate effectively within a team, and understanding the importance of listening to others' idea and respecting different viewpoints. And here I can mention that students are mentoring each other. They are giving feedback to each others, and the role of the teacher is a facilitator. So they don't have this issue to ask the teacher, or because in our class, in our inclusive classroom, we can have students who are shy, we can have students with disabilities. So these students, we need to take care of them. So the teacher has to adapt his teaching strategies to these students. Community engagement also, it's a very important skill. We encourage students to identify problems in their local community that could be addressed with robotics. This helps them to understand community needs and the impact of their project. For example, if we create a project for the environment, so for example, I am working with my students on a smart irrigation system. So we have the garden of our school, so the plants need water. So how we will save water? By creating a system that if the plant need water, so we will just need we will just give what the plant needs. So we will save water that way. So these skills are very important in for the students, for their career. Also, they can build a relationship. So robotics education provides ample opportunities for students to build and strengthen relationship with their peer by working together on projects, negotiate and support one another, based on trust, respect and cooperation, promoting a sense of belonging, peer mentoring also. When I put the students working in groups, so the students the students who are more experienced can support and guide their peers. And in robotics also, student must make decision so about how to design and use their creation. So we will foster the responsible decision-making skill. I will move on to the, for example, I will show you a video
Sorry, I
the time?
interrupted you. Yes, yes, maybe we can keep it at 12 minutes, so we show the video of the classroom. Thank you so much.
On 29th May, the eSkills Malta Foundation team visited one of my lesson. During this lesson, my students were working in collaboration to build an automatic barrier gate using Arduino. So this project involved various components, such as an Arduino board, ultrasonic sensor, and a servo motor, demonstrating the practical application of the tools and concepts I discussed earlier. The collaborative efforts of the students showcased their creativity, teamwork, and technical skills. Now I will hand it over to Mrs. Marisa to show you the video, a short video of 3 minutes. Thank you.
Thank you so much, Mr. Mohammed. Thank you. Let me share my screen.
Okay. Thank you, Mohammed, for your enlightening, really enlightening presentation. I really liked it. It shows us well how deep you go into the ISO flow charts there, which is really good. Okay. Now we come to the Nathaniel. A quick introduction to Nathaniel. Founder and director of Nobel Courses. He's got a strong background in coding, IT skills, and also business. And hence, that's why he opened his business, Proset, to see such a young person applying to this challenge. Nathaniel has been successfully expanded his company anche to Macedonia, and has been invited to speak in different schools, apart from Malta, also in London, and I suppose also Macedonia, on this topic. Online at times, about safety for kids. And his expertise and dedication to making education enjoyable are evident in his innovative approach to teaching and learning. Nathaniel, it's in your hands now. Ross.
Firstly and foremost, thank you, Karen, for the introduction, and thank you for the whole eSkills team for organizing these events and your initiatives. I do want to start off that the fundamentals of us at Noble Courses, it is to make learning and education as enjoyable as most as we can for everybody, for all students. And one of the main topics when it comes to robotics, it is the coding skills. I'll try to keep this part as brief as possible due to the time. As you all mentioned as well, when it comes to coding skills, there are both the tangible and then there's also the soft skills. When it comes to soft skills, children will be learning as well about decision-making, leadership, problem solving. As we all know, when it comes to robotics, there's always some sort of issues that come up. The robot is not moving, the battery is not connected properly, the code isn't working, or it was working, then it's not working again. So there's always these sort of issues. And then it's up for the kids as well to discuss together, work as a team, try to solve these issues, and then help each other out as well. And that builds up the teamwork and collaborative skills together, while also learning about the STEM education. So they're building the robots, they're learning about sensors, they're learning about Python, they're learning about coding. And those are the skills when it comes to coding. One of the most important topics when it comes to coding as well is if you take a look around your room or wherever you are at the moment, there's some sort of technology. Right now we're on the computers. And we're teaching as well the kids the back end of these type of technologies. So yes, they know how to use the phones, but how is the application working? And how I like to explain coding to these children is coding is just a language. Similar to the language that we're talking to right now, we're speaking in English, sometimes in Maltese as well. But this time we're talking to the computer in its own language. And when we talk to the computer, we're giving it commands. We're telling it what to do. And that's basically all about coding and the skills. So we can move on as well to the next slide. And here are a few different events where we went out to the public. Here are 4 different pictures. And the kids were building the robots. They were learning about how the robots work, the ins and outs, building it from scratch, and learning about also coding. While at the bottom left picture, they're also having fun with them. Because we do believe that they should learn, but they should also play with these stuff. They should have fun with them. They've built it, they've coded it. Then it's time to also enjoy and perhaps do a race, battle them against each other. And I remember when I was younger, we had these activities as well at Santa Agata, where we had to battle these robots. And that's what I noticed as well. Apart from learning about STEM education, there's a theory that most of the time is underlooked. It is the VARC theory, that there are 4 main methods that children and adults, everybody learns through. There's the visual, there's the auditory, read, write, and then there's also the kinetic, where you go hands-on. And that's why I believe that robotics captures all these different models in one. So at the same time, we're targeting all the children and not excluding anybody out of the picture. That's why they enjoy it, they're having fun, and they're seeing visually, they're listening, they're trying it out, experimenting as well. And at Noble Courses, that's something that we also believe, that learning should be done through experimenting, not just through theory. When I was younger, most of the coding, I learned it through theory. But nowadays, it's much different. They can learn the theory, then they can apply it as well. That's all for this slide. So this is one of the coding that they'll be doing. It's more visual. It's similar to Scratch. They're connecting blocks to each other. I like to explain this similar to Lego blocks, connecting them to each other. But then they also have the option to learn with Python, which Python is one of the most sought after languages at the moment. Going back to the importance of coding, there's also the future job opportunities. Nowadays, most of the jobs, one of the most expanding job sector is in technology. And giving these children the opportunity to learn at a very, very early stage about coding and technology gives them a bright future ahead of them as well. As you can see, the coding is much visual, and they can test it out, see the robots work, adjust it, change something different. And they're learning as well, apart from computational thinking, they're learning as well about problem solving, how to solve a problem, and then somebody needs to make a decision on that as well. So they're learning about leadership all at once. We can go to the next slide. Now, the eSkills team, they quite know me now, and I always love to add competitions to these stuff. I do believe competitions, there's something good, and at all, most of the times we do need to have some sort of competition, even for the children to push themselves and to work even harder. So these are two different competitions at two different schools where they're building the robots, they're creating them, and this is something that we will be doing at Scuola Saif. The robot will basically be following a line, and they can be creative and design the lines however they want. They can add books, and the robot has to go over them or go against them. And this is something that they will be doing. We'll be taking pictures from all the different schools at Scuola Saif in Malta. And then at the end, one of the problems that James also highlighted was the robotic kits. They're quite expensive. And yes, most of the schools, they don't have that type of budget at the moment. And those schools that win this competition, they will get donated as well the robots for the schools and also a medal. So it's also an incentive for the kids to push a bit harder, and they'll be more interested as well. They'll work together and they'll be much more interested and have much more fun as well while doing it. Basically, that's all from that part. Once again, the benefits for the kids would be about creativity. Over here, when they're doing the competition, they can be creative. And we do believe a lot that we should never limit a child's creativity. They should be creative, and there should not be a limit to their creativity. So if they want to add anything when it comes to obstacles, when it comes to how to design the robot, what type of designs and arts, they will be creative, and they can basically do whatever would be possible at that time when it comes to these robots. So basically, that's all from my end. And thank you.
Thank you, Nathaniel. Let me see. Okay, we are at the end actually, but before I give, I don't know whether I should risk. I think Marisa's is probably, let me see if she's looking at me, how she's looking at me. I don't know if anybody wants to say something, you know, at the end. What I've seen is very good projects, very good, let's say, initiatives, both from the chair schools and from the government schools. Two perfect examples, which can be used as best practices as well. Before, obviously, the importance of I'd like to make an accent as well on the importance of robotics in the curriculum and extra curriculum. You know, sometimes extra curriculum is difficult because it's in the evenings and it's very hard for the parents as well. But it's important, and the bridging of coding and computational thinking. I think there's a lot of competence. I saw from both videos, I saw, let's say, an exact image of, you know, how I would want, if I was young, to see computer science. And it's good to see, for instance, the flowcharts. These are all things. The important thing, I think, as a takeaway and importance is that sometimes there is a disconnection between, these are secondary schools, the primary and secondary, and then post-secondary. I think if we want to nurture and develop students to maybe even join ICT, because obviously what I've seen there are the ingredients for people to actually go for that. But there needs to be that connection between different levels of schooling, so that, you know, you do a lot of good work, Savio, Saint Benedict's, but then it would be probably a pity if they are not, either don't get the right career guidance, and maybe also if they go to the post-secondary, they get lost, and, you know, the opportunity that they have had, they would have lost. I would like to thank you all. I will, if you don't mind, obviously, we are in a number of projects, and some of them are European. We've got the EU Code Week coming, a project which we're working on. We will knock on your doors. Hopefully, we'll find the door open as well to do similar things like these, because, you know, events, and I'd like to see maybe in others, teachers encouraged to obviously make it a bit longer, bigger, you know. So thank you all, and see you soon, I guess. Thank you.
Thank you.
Thank you.
Thank you, everybody.
Thank you.
Bye.
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 Thank you very much.
Bye. Thank you.